What are the carbon-negative foods that are vegan and require the least water and input? Carbon-negative vegan foods are those that sequester more carbon during their growth than is emitted during their production. These foods typically have low resource requirements and often contribute to soil health, biodiversity, and climate resilience. Below are some examples of carbon-negative vegan foods that require minimal water and inputs. 1. Seaweed. Why it's carbon-negative? Grows without the need for soil, fresh water, or fertilizers. Sequesters large amounts of carbon dioxide as it grows, reducing ocean acidification. Water and input requirements. Thrives in marine environments, requiring no fresh water. Minimal human intervention beyond setup and harvesting. Examples: kelp, nori, wakame. 2. Cactus pear, prickly pear. Why it's carbon negative? Absorbs carbon dioxide efficiently, especially in arid environments. Can improve degraded soils and reduce desertification. Water and input requirements. Extremely drought tolerant, thrives in arid and semi-arid regions. Requires minimal maintenance and no chemical inputs. 3. Bamboo shoots. Why it's carbon negative? Bamboo is a fast-growing grass that sequesters significant amounts of carbon in both its biomass and soil. Shoots can be harvested for food without killing the plant, ensuring ongoing carbon storage. Water and input requirements. Requires minimal irrigation once established. Grows well without synthetic fertilizers. 4. Millets. Why it's carbon negative? Grows in poor soils and sequesters carbon in the soil through its root system. Its production emits very little carbon, making it a sustainable cereal option. Water and input requirements. Highly drought resistant, requiring far less water than rice or wheat. Thrives without synthetic fertilizers. 5. Legumes, e.g., lentils, chickpeas, peas. Why they're carbon negative? Fix nitrogen in the soil through symbiotic bacteria, reducing the need for synthetic fertilizers. Builds soil health, enhancing carbon sequestration. Water and input requirements. Require less water compared to animal protein or water-intensive crops like almonds. Thrive in a wide range of conditions with minimal chemical inputs. 6. Perennial vegetables, e.g., asparagus, artichokes. Why they're carbon negative? Perennial crops store carbon in their roots and soil over multiple growing seasons. Do not require annual tilling, which releases stored carbon from the soil. Water and input requirements. Require moderate water but much less than conventional annual vegetables. Minimal chemical inputs due to established root systems. 7. Hemp seeds. Why they're carbon negative? Hemp plants grow rapidly and sequester large amounts of carbon. They also improve soil structure and reduce the need for pesticides. Water and input requirements. Requires moderate water and grows well in various climates. Minimal chemical inputs compared to many other oilseed crops. 8. Tree nuts, e.g., chestnuts. Why they're carbon negative? Nut trees sequester carbon throughout their lifespan. Chestnuts, in particular, require less water and inputs compared to almonds or cashews. Water and input requirements. Require moderate water, far less than almonds. Minimal need for fertilizers and pesticides in well-managed systems. 9. Wild rice. Why it's carbon negative? Grows naturally in wetland ecosystems, which act as carbon sinks. Does not require synthetic fertilizers or pesticides. Water and input requirements. Requires standing water but utilizes natural water sources like lakes and rivers. Minimal human intervention required for growth. 10. Quinoa. Why it's carbon negative? Adapted to high altitudes and poor soils, it contributes to soil regeneration. Its minimal processing and low carbon footprint during cultivation make it a sustainable option. Water and input requirements. Requires less water than rice or wheat. Thrives without significant chemical inputs. General characteristics of carbon-negative foods. Perennial crops. Reduce tilling and allow long-term carbon storage in the soil. Drought-tolerant species. Require little to no irrigation, minimizing water usage. Nitrogen-fixing crops. Reduce reliance on synthetic fertilizers by improving soil fertility naturally. Marine-based crops. Utilize ocean environments without competing for freshwater or land resources. By focusing on these foods, you can support a climate-positive diet that minimizes environmental impact while contributing to carbon sequestration.